Hello everyone, my name is Márton. I work as a developer advocate at JetBrains, and today I want to talk to you about Compose Hot Reload, which is one of the super exciting things that we built recently for Compose. I've been using it since last November, so coming up on about a year now, but it was early developer builds back then. Now we're closer to making it a stable technology, but you can already very much use it, and it really improves your experience when you're editing Compose code. So let me start by giving a bit of a demo to actually show you what it's like to use in action. So I have the Kotlin conf repo cloned here, and I'll go ahead and find my main function first of all. So I'll hop over to the main function, and I'll make sure that I have the Kotlin multi-platform plugin for IntelliJ installed. It's also available the exact same way for Android Studio in case you use Android Studio, which would also, of course, make sense. One of the things that this plugin gives me is support for Compose Hot Reload. So if I go to a Gutter icon with a desktop JVM main function, I can launch that application with Compose Hot Reload configured. And as I do that, it will quickly build, and it will launch the Kotlin conf app for us. Right? There we go. Once we have it running with Hot Reload, what Hot Reload gives us is that we can make changes to the code base, and they will be applied to the live running application without having to rebuild and restart it. So let's go, as a simple example, to the info screen, which is this one. We can also find the same thing in the code base, and let's try editing some of the UI code here. So let's say that we want to add some more spacing between all of these items. So we can find the column that's responsible for that, check out the spacing arrangement on it, and change it from 8 dps to like 32 dps as an example. And as I save the file, we should see Hot Reload kicking in. It will build the new version of the code, and once the code is done, it will load the changes into the application. So I didn't need to restart this. I stayed on the same screen where I already was, and the changes were applied. We can also make other similar changes, of course. So if we want to change the spacing for these icons on the bottom as well, I can put in like 32 dps of spacing there. And as we go along with more and more builds, and if I wasn't screen recording and charging, it would also be a bit faster. Of course, I'm showing you this with a real full application. If I was doing this with a Hello World demo, it would be even faster. On a modern machine, it can come down to sub-second hot reloads. But this is also quite fast. And of course, it preserves as much state as we can manage to preserve for you. But small edits like these are already quite useful for tweaking your UI, but we can do a lot more if we use Hot Reload. So for example, we have these social icons down here on the bottom. Let's say that I want to remove one of them, so I can make a structural change to my code, remove a bit of Compose code, and as a reload happens, we'll see that now we only have 2 social icons on the bottom. So you can make structural changes like this as well. Or let's say that I want to modify what these look like by adding a new column in here, so that instead of a single image, we'll have a column as well as a piece of text. I can use the description that we already have for the image as the text here and see what that looks like. I obviously broke this quite a bit. The images are gone now, so I can start fixing it up, which I can also do with more hot reloads. So I can take all these modifiers that were on the image, I can move them up on the column and see how that works. And well, that still doesn't quite work. I probably want to align this, center it horizontally, and probably make it a bit larger so that the text also fits. And you can see how I can really nicely iterate on my UI code here without having to relaunch the app. I just save the file, and within a second or two, it loads into my live application. Let's see what else we can do. So far, I made structural changes here, but I didn't touch any of the larger structure of the code. So I was still just working in existing functions. But with Hot Reload, you can actually make almost arbitrary changes, and Hot Reload will be able to reload them. So if you want to introduce new functions, new classes, new files, that will also work with Hot Reload. As a quick example, let's just extract some of this code. to like a social row, make sure that it's a composable, of course. And if I save that, we'll see that this will also successfully reload. And just to demonstrate that the code is still running, let's change like a weight in there. And once that reloads, we can see that everything is still working. All right. Let me show you one more thing before we get back to the slides for a bit of explanation of what's happening. And that would be clicking some of these links here. So we have a Slack and a Blue Sky button. We, of course, expect these to go to Slack and Blue Sky respectively. But as you see, as I'm clicking the Slack one over and over, it actually goes to the wrong link, right? So we can start, we could start debugging this and seeing what the problem is. We can hop through all of these usages, see where the screen is called. And it looks like these are hooked up correctly. On Slack, it opens the Slack URL. On Blue Sky, it opens the Blue Sky URL. But if we go in there, we can see that the actual string constants are mixed up, right? And that's actually something that we can also hot reload, even though these are like static compile time constants here. So I can just swap the Slack and the Blue Sky URLs, save the file to trigger hot reload. And once the reload is done, now if I click the Slack icon, it opens the correct link. So not only can we change direct UI in Compose, but we can also kind of change the business logic by just editing that code. One more thing that we can look at, which is quite interesting with hot reload, is working on animations. So if I go to the settings screen, we have a neat animation here for going between dark and light theme in the application. And let's say that I want to make this a bit nicer still. So this is implemented somewhere in the settings screen, and I can find the animation right here. And with hot reload, you can really iterate on your app and see what it feels like in practice. Let's say that I want this animation to be slower, for example. I can simply change the animation timing, wait for the reload to happen, and now if I click this again, I have a slower transition between the two states. Or if I want to change the easing of this animation, maybe try, I mean, there's so many options, right? Like ease in cubic. Let's see what that looks like. We just hot reload, and now we have like a bit of acceleration as the transition happens. Or I know that there's like nice bouncing animations that we might want to use, so we can just try an ease out one. And well, that's maybe a bit too bouncy. We can again like try a different one. We can try making it like a bit faster. Again, like really quickly and easily, we can just experiment with different values and constants. And that's probably good enough. So I think I'll leave it at that one. Of course, here we were also like adding new imports all the time. So as I was like accessing these new values, which weren't used in the file before, things like new imports also work and hot reload just fine. All right, so let's go back to the slides and talk a bit about how all of this works, because it's kind of magical that you can just make any code change and it just gets applied. So the way that you would set this up is you need a Gradle plugin at the moment. We'll probably merge this into the main Compose multi-platform plugin later on, but for now, having separate releases lets us ship hot reload versions quicker than Compose hot reload releases, so it's a separate plugin. You'll also need this resolver convention in your settings.gradle file, which we'll come back to in just a minute. And if you are not using Kotlin 2.2 yet, so if you haven't updated since June, first of all, you probably should bump your Kotlin version. And second of all, if you don't have Kotlin 2.2 yet, you should add this Compose feature flag, which makes Compose hot reload work just a bit nicer. But again, hopefully you don't need this anymore. So when you normally launch your app, you run a Gradle task for it. We're assuming Gradle here for the build system for the slides, but hot reload is actually agnostic of build systems, so it also works with Amper, for example. So let's say that you launch your application with Gradle. It usually launches the Java runtime and then loads the compiled code of your app in that runtime. This launch process is the first thing that we intercept by adding a bunch of extra configuration to the JVM that's launched, and among other things, making sure that the JVM that you use is the JetBrains runtime. The way that we do that is exactly with this resolver that we've set up earlier. So if you're using some other JDK or JVM, on your machine and you don't have a JetBrains runtime yet, this resolver will let us download it and launch the application using JetBrains runtime. Now, we're not doing that just for like branding reasons. There's an actual technical explanation for why we need this, and it's because this is the only version of OpenJDK that contains something called DCE-VM, which is an advanced way of redefining classes at runtime. And this is kind of the secret sauce that makes hot reload so capable of reloading just about any code change that happens in your app. Another thing that we do at launch is we attach a Java agent inside your process, which is responsible for a lot of the computation and the main processing of hot reload. This also talks to other components, such as the recompiler process that we launch. In the case of Gradle, this would just be a continuous Gradle build, which, whenever file changes happen, rebuilds the changed files. It will pass back the results to the hot reload agent, and then the hot reload agent can swap that new class into your already running application. It can detect where the class that you have just modified was used within the app, like which parts of your compose hierarchy have used that specific code. And then we can talk to the compose runtime inside your application and invalidate some of your groups. So basically, recompose the parts of your application that relied on the code that just changed, so that the code runs again and the UI is updated. There are also other components which communicate with all of these other parts, like the developer tooling window. So if I drag this around, it will become a bit more obvious that we have this little widget here, which is attached to the side of our app. This window contains some of the logs and some actions for compose hot reload, and it also serves as a status indicator, in addition to the various animations that we are adding to the app. So that dev tooling window also communicates with all of these other parts. For example, it gets the latest state of recompilation from the Gradle build. And of course, we also get information from your application's code, for example, the current position of the window, so that we can drag the dev tooling window alongside it. You can imagine that a lot of other things can be attached to this system of components. For example, if we want to build an IDE plugin or integrations with other build systems or any other tools or plugins, these can also communicate with all of the other parts of hot reload the same way. All right, let's talk a bit more about DCVM, which is how the reloading actually happens. So the way that this works is that, let's say that we have our current version of a class. It's a class with just a single int in it, and this is our current class loader where all of our classes live. When you change the class, for example, by adding a new property to it, we create a new side universe where a different class loader exists. Here we verify that DCVM can actually move classes from one of these, from the old one to the new one. And then we migrate all of the objects that are already in memory for this class to the new version. And then that side universe class loader becomes the primary class loader. So what do I mean by just migrating objects from the old version to the new one? Let's say that we keep this same example and we have a bunch of instances of this offset class somewhere in memory already. These will have some object header, which every JVM object has, and then they will contain all of their fields. So in this case, it's a simple int value, so it will just directly contain some int value as part of the memory allocated for the class. What we need to do here, as we add a new property, is allocate new memory for each of these offset instances and move them from the old location to the new location, also adding space for that new int that we now want to store in there. So for any existing fields, like the header or that first property, we can just copy the contents over. And for anything that was newly added, we simply use the JVM defaults. So for numerical values, this would be 0. For reference types, we would set them to null. And once this is done, we just remove the old version of these classes, and now these are the new representation of each of those instances. If you think about it, what we do when we perform this kind of swapping is basically just a very special garbage collection pass, because we need to pause the execution of the app for just a moment and then move some objects around in memory. After we did this swapping, we still need to figure out which part of the code was changed so that we can rerun some of your compose hierarchy, as I mentioned earlier. let's say that we have this code which has a basic counter and a button that makes it count upwards. We also have that function on the top which has a padding value where it just returns 16 dp. When we change something like that function, hot reload performs a bunch of complex hashing in the background and figures out exactly which part of the bytecode in which function has changed. So it would detect that that function has changed its body implementation. It would also track that, based on these hashes in the background, that this affects this place in the code where that function was used. It would find the closest compose group that we can invalidate. In this case, that would be the card. And it would just drop the state of that card and rerun that. So by that being modified, it will call the function again, hit the new bytecode, and the padding value will effectively change. In this case, as we invalidate the card, the state that's right above it would be preserved because the card scope is the only one where we drop the state and invalidate it. Let's take another example though. Let's say that we modify some of the text that this composable is displaying. In this case, the closest scope that we can invalidate would be the entire body of the counter function. So here we would actually have to drop that state that's declared on the previous line. In general, we try to make sure that whatever you see in your running application always shows you the latest state of your code. And when we need to decide between dropping more state and, well, between keeping more state and showing you the correct results, we always choose to show you the correct results of your current code and prefer dropping some state if necessary. But we are also working on minimizing this further and keeping as much state as we can, while still keeping all of the correctness. All right, let's get back to the demo, and I can show you some other things that we can do with hot reload. So let me hop over to the speaker list here and search for example, all of the Sebastians that have given talks at KotlinConf this year. We can also hop over to the speaker screen and think about editing some of these cards here. As I hop into the speaker card component, I just want to highlight that this one is actually declared in a separate module. So this speaker card is part of our UI component setup, whereas the application itself lives in the shared module. Hot reload also works in this scenario across modules. Again, it will be a bit slower because we need to build a bit more as the changes happen. But that is basically just dependent on how fast your build and your build system generally is. But the point is that hot reload handles things like multi-module projects without any problems. So here again, we can really easily iterate on some of our UI. We can try like a different size for our speaker images and iterate on the exact size that we might want those to be. We can hop into that component. We can try clipping it into a circle instead of a rounded rectangle. And all of these things hot reload nicely, and we can see how the application feels after we made these changes. We can also play around with things like the speaker grid here. Right now, if I resize the application, you'll see that this is just a 2-column grid. But of course, we can change that. We can change things like constants, which are obviously quite easy to swap. So if I just change this to like 3 columns, then now we have that. But we can also make more interesting changes. For example, I can change this into an adaptive grid and give each speaker maybe 300 dps of space. And now as I resize the app, you'll see that this grid rearranges itself nicely based on the available space. I should also, at this point, show you a compilation error, because I forgot to do that until now. What happens when you break your code and try to do a hot reload? We'll do the reload animation again, but this time we'll give you the broken state. Here, of course, your application is still functional. You can still click around it. We just put some indication on it so that you realize that you have a compilation error. You can check the logs to see what happened. We're working on putting this into your IntelliJ run window as well. In nightly builds, it's actually already there. And of course, hot reload can recover from states like this. So if you go back to code that is valid, then you get back to green, and you can continue editing from there. Right. I want to show you one last scenario where I'll edit some business logic as opposed to UI. So we'll hop over to the schedule, which has a feature where you can filter for just your bookmarked sessions. And if I scroll through, you'll see that I have 2 sessions here, which are bookmarked in the app. One of them, by the way, is the hot reload session from KotlinConf, which you can catch on YouTube, and it has really much deeper technical details about how all of this works, including the hashing magic and all of that. So when we're in this view with the filtered mode of the schedule, you'll see that any time slots where I didn't save something look kind of empty, and it would be nice to add some more items to the schedule in this case, which is essentially a new feature for the schedule screen. So I can hop over there and actually go to the view model, which contains the logic for setting up all the items that the list displays. And I can add a new item to the sealed hierarchy that defines all of those items. So far we had day separators and time slot titles and sessions. Now I'll also have an item which will just say no bookmarks in the case when we have an empty session like this. If I want to do this, I also need to modify some of the business logic in the view model. So I'll just add an if statement, and if the scenario happens, then I'll add some more items to the list. And this function that I'm editing here is just some private function in the view model. So it's purely business logic. But I can also reload this change, except, of course, I forgot to implement this on the UI side. So I can quickly do that. Add a quick ID here, hop to the next problem, make sure that we have a branch for this. And for the no bookmark case, let's just put no bookmarks yet on the UI. So with this, I think I've implemented handling that new item everywhere. And I have that code in the view model, which would add these items. But because this is not part of my composable code, hot reload has no way of invalidating my UI and reloading it, right? The code I edited is, again, just some function in a view model. Hot reload has no way of rerunning that function of the view model. We don't have the context for that at all. But if we check where this happens, it happens as part of creating the UI state, combining a bunch of different Kotlin flows. And if I just change one of these flows, that will make this code run again, and it would run the new version of the code. And the easiest way that I can do, that here would be toggling bookmarks on and off. And now that the new code has actually run in the view model, we now have brand new items here. And again, we even edited things like the sealed hierarchy that powers all of these items. And of course, from here, tweaking this UI-wise is kind of trivial after seeing hot reload so much. So adding something like a bit of probably just horizontal padding, or setting up some color on it is fairly trivial from here. So we can make this a secondary text, probably format the code a bit. And as that loads, because this is a UI change, you'll see that now the color changes and the paddings have been changed automatically, because these things are part of the UI, and we can just invalidate them. All right, back to the slides. So if you want to try compose hot reload yourself, you can go to the GitHub repo, check out all the instructions. There's a sample project in there, and you can get started with it already. It's currently in beta 7. I'm already using beta 8, and it's quite soon going to be stable. Now, yes, all of this works with the Compose desktop target. So this is the desktop JVM target. I explained that we need the JetBrains runtime for the special code swapping. We will be looking at other platforms later, but for now, you will need a desktop target to do this. So, for example, if you already have a shared app between Android and iOS, and you are running that with Compose, something that you could do, like we do with the KotlinConf app, is just have a full desktop app on the same stack as well. So it could use the same UI, same view models. You would have to make sure that whatever your data layer consists of also supports desktop. So if you have networking code or a database or something like that, you'll also need to make sure that that also works on the desktop. Again, this is what we do for the KotlinConf app, but it's not the only option. If you don't want to connect all of your data layer stuff, like you have permission handling or Bluetooth, and things like that that you don't really want to properly implement for desktop, just for development, then you can have a completely fake data layer. You can just inject some fakes when you start up the desktop app through your DI setup, and you can use those. Or you can have an app which isn't your full app. It might not use your real navigation, your real data, your real view models at all. It can just be some JVM desktop application which runs Compose and contains some of the UI that you also use in your Android and iOS apps. So this could contain individual screens with fake data. It could be like a gallery kind of app where it's just a list of all of your components. Whatever you can get into a Compose application on the desktop that you want to iterate on can work with hot reload. I wanted to show you, I think, 2 quick demos of how we use hot reload ourselves, just as like something interesting from within JetBrains. One of the places where we use hot reload is actually the JetBrains Toolbox app, because that is a desktop application using Compose. So you can see here that as we're editing some of the text, and we're going to add a font size, but once that is saved, we'll see a reload indicator here, and this will pop up in just a moment here. So we can use hot reload even for developing Toolbox ourselves. And of course, I've shown you that chart of all the different components and how they connect, and I really wanted to emphasize how there's a lot of flexibility in where you can hot reload. And that means that hot reload doesn't just work for standalone Compose windows, they also work in other situations. For example, you can run Compose as part of the UI of IntelliJ itself, and hot reload will also work for that. So on the bottom here, we have an IntelliJ instance which has the code base for IntelliJ open, and then that's running the IntelliJ on the top here in debug mode, right? So we're developing the IntelliJ code base here, and that's running IntelliJ on the top, which is something that many engineers do at JetBrains, as you might imagine. And because we can now write Compose code to build IntelliJ UI, we can actually use hot reload in that scenario as well. So instead of having to, well, write Swing code, but also rebuild and relaunch IntelliJ and get a project open and get it into a correct state, we can just use Compose hot reload, change some of our Compose code, and it will hot reload right inside the live running instance of IntelliJ. And that's something that you can also do if you want to develop your own IntelliJ plugins, for example. And with that, I think we're right on time, which is fantastic. That was blazing fast UI development with Compose hot reload. I hope that you got inspired to try Compose hot reload yourself. If you don't have a better sample, the Kotlin Conf app is always there. It's open source. It's available for all of the platforms that we support. And of course, it's set up with the latest version of Compose hot reload. And I can also really recommend checking out all of Seb Selmayer's content, who is the main author behind Compose hot reload. And he gave a really good technical deep dive at Kotlin Conf about it. And he has also written some things on his blog explaining how hot reload was built. That's everything. Thank you.